Hello, trying to put things. Okay. Oh, but I move the webcam. Yeah. It's okay, because I want to be able to talk and maybe write on the keyboard at the same time. So, okay. So we'll have this workshop about. I wanted to show you the last things I've been doing on Heaps.io and HashLink. So, how many of you know about Heaps.io? Heaps framework. Right. Okay. So. Heaps is a 2D and 3D API. I started working on a few years ago. I think it's 4 or 5 years ago already, maybe less. And so I started first adding a 2D kind of display list, and then I added 3D, so it has both of them. And so it's pure Haxe, so it's entirely written in Haxe. So it's not like there's not so much native parts. It's GPU based, so it means like I haven't tried to kind of take into concerns falling back on Canvas or some like not GPU powered devices. So it's entirely designed around the principle of having a GPU, having texture where you upload buffers, shaders. So it's that's the kind of world design is kind of modern API. It has something called HXSL, which is a X shader language, shaders that I might show you, which means you can write your own shaders in Haxe code. So it get compiled to macro, and they can get all integrated in your code. It's a toolkit based, so it means it's a set of, you have different display lists and a lot of tools. You can assemble together to make your games or applications. So I'm trying to keep minimal amount of dependencies to the native layer. So I have a driver system, which is basically a 3D API driver. System tools for just handling a few things such as events, mouse, keyboards, gamepads, and sound support. So just have a few, I think there's 3 or 4 classes that actually contains the native parts. And all those other classes are based on this native parts and built on top of it. So Heaps compiles to, it used to compile, it still compiles to Flash and Stretch 3D, but you know it's dying. So, well, if you still have Flash content, you can publish to it. It compiles to JavaScript and supports WebGL 1.0. I'm planning to add support for WebGL 2 when it becomes a bit more mainstream. So you can compile JavaScript, and you have a canvas and works well. It's compiles also to HashLink, support with SDL. And DirectX layer also, HashLink DirectX. So you have when it runs on HashLink, you can choose either to use SDL. It creates SDL window, so it works on OS X and Linux, and use OpenGL for the driver, Street driver, and or you can compile on just Windows and using Windows API for creating the window, and it uses DirectX for the rendering, and gamepad and sound. So yeah, you have many choice. It's also it's using the cross-platform capacities of Haxe quite a lot. So, and I added support for PS4 as well. So if you are a registered developer on Sony PlayStation, you can get there's a few files that is not public because the frameworks themselves are not public. So, but if you are a registered developer, just send me an email and I can get them to you, so you can run HashLink on PlayStation. And we are working on adding Xbox and Nintendo Switch support as well, using HashLink. So, and also some people contribute OpenFL Lime support for Heaps, but it's not officially supported. I'm not working on it, so I don't test it, and hopefully when I'm sending things, it breaks. So I think it's not working well. But if you if you are interested in contributing, it's not too much change to make it work on Lime as well. So today's programs, we'll try to install and compile and run Heaps samples. So it's a workshop model. So bring out your computers if you have some, and turn them on. Well, you can follow what I'm doing if you don't have your computer or something. It's okay. We can install, compile, and run Heaps sample. Like you can get a gift of it, or you just can watch me doing it. And so we get the start of the API, trying to understand how it works, what kind of the possibilities there is. I will show you a bit also about the tools I'm working on. We are using at Hero Games. Hide is a start of an IDE I did just a few months ago, working on some kind of IDE to have different tools working with Heaps. And CDB is a tool I've been using also for some time for handling some data, like database stuff. And on the workflow, so how do we kind of bring the resources together, compile them, and run the game. So I will show you a bit different steps we are using in our games to with Heaps. So, and I will be able to answer your questions you might have. So let's start. So first, I want to ask you, like quite openly, what kind of expectations of the workshop, what kind of things you want to learn about, because I don't know, I know some of you, maybe half of you, but I don't know all of you, and so I want to take notes about what you want from this workshop to do and what you want to learn. So please raise your hand, and I will write down this, and then that will be our program for today. So, any expectations about the workshop? What do you want to learn about Heaps? What do you want to learn about? Yeah.
Simple free app in Heaps and compile it to HashLink and then to see and run it on iOS and Android.
Okay, you want to see? You want to see this? Want to see this compilation? Okay. So how Heaps HashLink compilation workflow. Let's say workflow. Okay. And put it a bit bigger, maybe. Is it just block now? Oh, okay. I don't have font support in this. Let me open again with this. A lot better. I can't. View. How do I make it bigger? Yeah, control. Yeah, oh, see, that's what control here. Yeah, thank you. So, can you read? Yeah. So, other expectations? Yeah?
I use Lime for
Yeah.
a kind of SDL requirement set of
Yeah.
features. And Lime is good, but it's driven by the needs of emulating Flash and OpenFL.
Yeah.
And so I'm interested in an alternative.
Okay, so I like alternative API to Flash. Yeah? To Flash, Lime,
SDL.
or to SDL. Okay. To SDL. Okay. Yeah.
I'm pretty familiar with OpenFL and the process of game development there. I want to get familiar with Heaps, at least until I be comfortable enough to start my own mini game.
Okay. Okay. So get comfortable. Comfortable. As it says, M, right? In French? No.
Yes.
Yeah. Okay. Thank you. Get comfortable with the API, I say.
With the API, I can read
and workflow.
But with the workflow,
Yeah.
the culture of
Yeah. Okay. Okay. Workflow. Okay. Yeah.
Yeah, is this how you have some network implementation? So in Heaps, right?
The network parts have been moved out in a library called HashLink, which I can show you. Yeah. I can.
So like
Yeah. Okay.
network interactions with this.
Networking with HashLink. Yeah, I can show you that here too. Yeah. Sure. Yeah, Mark.
How to work with assets and animations.
Animations. Yeah. Sure. Other? Yeah.
Is something like preview the previous scene?
Ask me.
Any kind of preview for this scene, or do you code anything to compile and see how it looks? How do you iterate on like?
Okay. Like previewing like viewing the C code.
For this scene, basically.
Sorry, I don't get it. I don't hear.
This scene?
The scene. Preview of the scene.
Yeah.
Yeah. Scene preview. Okay, so kind of. Yeah. Okay. Or to look at the assets. Yeah, okay, I have that. Yeah. Sure. HTML target.
Yeah, and loading assets at runtime.
Loading, runtime loading. Okay, I can show you that. Yeah. Sure. Interesting.
3D object file or something similar?
3D.
A 3D
OBJ file. Okay, we don't use OBJ with FBX, but yeah. Yeah, 3D FBX support. Okay. Yeah.
HXSL, very interesting.
HXSL, yeah, shadow language. Anybody of you have been writing shadows already? No? Not much? Yeah, you did? Okay. Something else? Yeah?
Maybe like a just basic 2D thing for any.
Basic 2D, okay. So 2D one-on-one. Okay. Okay. Nothing else? Okay, so let's get started. So I will try to sort things out in the most good way of doing this. Compilation workflow. Let's look at the API with a basic first 2D. Then let's get more comfortable. I will keep the network for a bit, like some more hardcore topic. Animations and preview. Okay, I can put that here. Animations. Animation HTML targets, runtime loading. Yeah, let's do it for this right now. Okay, so compilation workflow. So if you want to just do what I do on my computer, I think, well, you could install X4 and HashLink, but that may be a lot of things to download, and maybe the Wi-Fi is not very good. So try right now to just do xlib install Heaps. I have already the version that should be compatible with X3.4 if you have it on your computer. And this way we can get started. So I'm using xdevelop from my old example. So, and I think there is a recording, so you can later watch this. So I will create a new, I will go for, instead of going HashLink for now, for the examples, I think it's much more easy if I go from WebGL. Like this, we don't have any like native things to install, but it works exactly the same with HashL. So I create a new project. Sorry, I can't zoom in for now. So it's a JavaScript project, and I go browse, and I put that on D right now. I will call it Summit, X Summit. Okay, I know the name is here. It's in the package name. Okay, and I will put here. There. Okay. So don't do that. I don't care. Okay. So we have a main main class. I will zoom. Okay. Can you see well enough? Yeah. Okay. So I remove all this junk stuff. Keep it small. Okay. So basically, when you use Heaps, you start with an application that extends hxd.app. Okay. I will get the compilation. It's better to link the library. So I go in the compile options, and that -lib Heaps, and that's all I need to do. We don't have any like a fancy build system that does a lot of things, but so, and if I run that, if I compile that first, okay. Oh, I should enable. I don't know if compilation server is enabled on this specific computer. What was it? Xcontext compilation server. Okay, so good, very good. So first time was and it builds I think XSummit.js, and I have HTML. Does it open? Yeah, it opens. Oh, it's open on localhost. I don't care about pathos. Oh, I will open on the directly. Oh, why don't web server? I think just open document. Okay. So here it opens the index HTML files, which I think includes the XSummit.js. Yeah, I just need to add the canvas, to it. Canvas style. I will go with width. I think it's width 100%, height 100%, and I think I need an ID canvas or something for it. I think that was it. If not, I will look at the sources. Still not it. Oh, I need to create the app. Okay. So I create a new main here. Here. Let me check if there's something going on in the console. Saying missing canvas WebGL. So there needs to be the idea of the canvas should be WebGL. So just zooming in things here. Okay, WebGL. So I have a canvas. It's not the good size. 100%. Okay, I think I need a style as well. Style width 100%, 100%. I think it was something like that. Yeah. So we got the canvas, and we just will remove the margin and padding from the body. Okay, and I think we got the canvas. So it's just displaying a black thing because we don't render anything. So we'll start adding maybe some 2D things. Okay. So when you have application, you have two functions that you can override easily. One is initialize, when you kind of do your initialization, or init, it's actually init function. You don't even need to call the super because it does nothing, it's just empty thing. And you can start displaying things. So we can create a new bitmap, for instance, BMP, got new H2D. So you have different package. H2D holds all the 2D things, and H3D is about 3D things, which is surprising, but still. Well, and so you create a bitmap. A bitmap needs two things. It needs first a tile and a parent. Parent is for the display, so where you put it. So for the parent, you can put so in the tile, and the parent we use the S2D var. S2D is a variable we have in our application. We have S2D and S3D. S2D is a 2D scene, so it's a root of the whole display list. And S3D is a 3D scene when you can add 3D things to it. Okay, so we put it as a root of the scene. And the tile is something the bitmap you want to show. So in Heaps you have a distinction between a texture and a tile. A texture is kind of a big image that you upload to the GPU, and a tile is a part of this texture. It can be the whole texture, or it can be only a part of it. So if, for instance, if you have a texture with many sprites into it, a tile is a specific frame of this sprite. So if for animation you can have, you can have many tiles using the same texture, but you can, well, it's a part of a texture, basically. So here we just create a tile from nothing using H2D tile from color. So here it will just create a texture in the background with a single pixel, and like this you can create a tile. So we just create a red tile, so it's FF, and we'll just, I think the screen is big, so we just go 300 by 300, and yeah, it's I need a variable for that. BMP H2D bitmap. Okay, so it shows the bitmap put on the screen. You have it like this, and then you can do update. You can update. Here you get a timing variable, which allows you to kind of, if you move things around, to have things moving. If you multiply by this dt, things will be moving at a constant speed, whatever the FPS the application is running on. So it helps you if you want to have precise timing, for instance, whatever. If it's a slow computer and you have a lot of things showing, or well, so here, for instance, I can rotate by dt multiply 1. So I just start rotating the bitmap, and you can see things start rotating. So it's rotate, but using its top left point. So actually, I can modify on the tile. I can modify the pivot using this variable dx, which is a delta of the center of the pivot for rotation and scaling and positioning. So, and because I'm doing this, I want to put maybe the bitmap at the center of the scene. So I will do the xVerge at S2D width multiply 0.5, and oh, what I'm right. and same for y8 multiply 0.5. Okay? Can close that for now. You can see the word code. So pretty simple. So, oh, well, what's the way it is here? I don't know. We have a very big canvas. I don't know why. Okay, maybe something with the style. Why it's so big? Well, I just maybe remove that. I don't know if it's a come from this. Yeah, it's better. Okay, so here you have rotating things. So now we want to maybe to put some image instead of, you know, having this just a color, because working with color is nice, but unless you're making a really indie game, it's not going to work out. You need actual pictures. So here we are entering into the resource system of Heaps. So we have I will explain a bit first. We have a resource system, resource manager called so it's in the HXD package. So in H2D you have everything about 2D. In H3D you have everything about 3D, and in HXD you have things like kind of common things that are shared between H2D and H3D. These are everything about the resources, about the sounds, about the some formats and events, well, these kind of things. So these are the three packages you will use daily if you use Heaps, H2D, H3D, and HXD. So I have a class called HXD res, so for resources, and I have several functions that I can use, which are actually macros, to initialize the resource system. There's 3 showing right now. It's maybe you can't read this, very small. I tell you there is init embed. Init embed is about initializing the resource system with what I call an embed file system. Embed file system use X resource API to embed directly your resource into your JavaScript file or your executable or anything. Well, it's just, you know, you put the kind of the resource inside the code. So it's very useful when you want to have small application and you don't want to handle a lot of files and files loading and everything. You just put the resource into the code and that's it. You know. So I think we will use it for the example, but I will we don't have only this. So we have also init local. Init local is only for system API. So for when you use a HashLink, for instance, or other like targets, OpenFL, for instance. It's based on the local file system. So it means that it will load the resource from the file system directly by reading the files in the directory at runtime. And the third one is init pack. And pack is it's reading the resources from a single pack files or for multiple pack files. You can have up to multiple pack files. And a pack file is basically a set of files put together and built together as a single big file. So the thing is that it's really all these file systems are using the same API, so you can extend them with new file system by implementing your own, and you have only one or two classes to implement to actually be able to read files, load them asynchronously, or check the content or something, and everything is built on top of this. So if you want to add, for instance, a lot of preloading stuff, or you just have to re-implement a few classes in the file system implementation to have your own kind of file system and use entirely the whole resource system of Heaps. Okay, so we will just first go with init embed. If you have any question, don't hesitate to ask me, because it's a workshop, so it's more interactivity. So if you have some questions, if something I say are not clear, don't hesitate. So we go with init embed first, and it complains about resource directory not found in class path res. So it said me I can reuse -d resource dir to a specific directory, but that they can't find the resource directory because we haven't created any. So we will create one. So we go on the project here, Haxe Summit, And by default, the name of the directory for resources is called res. So 3-letter, I like short identifiers. Res, okay? So we build it, compile, okay, we're done, and we run. So we didn't change anything, we just initialize the resource system here. And now we want to put some resource here, so I will just get some files from the, where do I get it? Projects, Heaps, samples. So yeah, if you want to look at, we have a lot of samples in the Heaps project on GitHub that you can look at with a lot of things I explained. They're not like you can look at the compiles, compile the code, modify it. It's a lot of things you can see. So I will take in the resources directory. I will get this beautiful X logo, and I will put it back here in my project. Oh no, it's not project. It's the Haxe Summit res. Okay. Xlogo.png. So now I have put my resource here, and I need to access it from my source code. So instead of using that, I will use hxd res, and I see here I have hx logo showing because of the completion. So it's kind of the things using macros is that you can get the macros to read your whole file system resource, and you get completion for all your resources, which is quite nice. I find it because if you rename the files, then you get a compilation error. So it's really kind of strictly typing the resources in your project. And at the same time, you can also load dynamically if you want using a kind of a pass, a string for the pass. It works as well. But you also have the completion for this, which is nice. So Haxe logo, and because we know it's a PNG, you can say directly, you can use toTile. It doesn't have, it knows it's a resource of type image. So yeah.
The tile is like a texture, right?
Yeah, so toTile is just making a texture and giving back the tile of the whole texture. Okay, so it's uploads, it's what it does when I do that, it will load the PNG file, put it on the GPU, take as a texture, create a texture for it, and then take a tile of it and give it back. And it's caching the results. So it means that if I do again the same thing, it will have a texture already available, unless it's been not used for a long time, in which case it's just because it's garbage resources, but that's a computation detail. So I'm doing this, and I have an X logo running, okay? So that's pretty easy to get started. So, so I can manipulate different variables. For instance, let's say to create, let's try to like more of them. How many of them do you want?
7.
Huh? 7,000 you mean? Huh? 1,000 is too low. Let's go with 100,000. Don't underestimate the GPU, guys. So I think we don't put at the same place because we don't see nothing. You will think I'm tricky. So I will just put at random place. Here. Here. And I will put some alpha because it's better, you know. As this we can show them like having them each other. And I will put into array. And push them here. BMP. And I will put a random rotation at first. Rotation. Match random. So they're not entirely synchronized. Okay. Oh. And for B in BNPs, replace. Okay. Oh yeah, B dot rotate. Yeah. Oh, it's I was a bit maybe too much. the alpha is killing all. I think we're eating some fill rate issues, not about almost even handle. Because if we put maybe like, I'll just try with 10,000 already. Yeah, this works quite well. Not real time. I think it's more about the fill rate here because it's a big thing. If we scale it down, we'll scale it down here. Yeah, that works a lot better. Yeah, because there's an overdraw. You know, like GPUs, you can be like bound by the number of things you draw, or also by the number of actual, fill rate. So how much things you draw over the others. So that's more of the problem here. Huh?
Without alpha?
Yeah. Without those alpha, it's, you still have some fill rate. Alpha does also the blending. So, and yeah, I can put maybe less alpha, maybe more beautiful. Yeah, all right. There's a lot of them. So,
It looks like curling noise.
Yeah. You can see all this X logo just. Well, just to show you can have many objects. Okay, so.
You get rid of the white background.
Can I get rid of the white background? So yeah, I can do it with a shadow. I think I have something color key. I still have it maybe, which has a shadow that kills all the. Yeah, that's it. Huh? Well. Yeah. Don't look at it too long if it will hurt your eyes. Anyway, so so just to complete a bit about the API, so to the API, so you have different properties on the thing. I did not go for all of them, but basically what you have also in Flash or in other engine like 2D engine. So you have X and Y properties. You have alpha, rotation, scaling in both X and Y. You can name things. You have everything. Everything is can be is a container. So you can put things into the bitmaps and everything. You don't have to. We don't have a separation between a child and a container. So you can put. If I want to add the BMPs all together, could be funny. But let's not do that for now. Well, you can change them and have them all rotate all together in without creating containers for it. And what else? Yeah, you have color operation, so you can do, like for instance, I can adjust color. I can use adjust color to kind of modify the hue. Here, I think it's an angle in radians so they will all have a different, slightly different hue. So you have a lot of operation like this you can do on the things which are accelerated by the GPU using shaders. So you can switch also about the brightness, saturation. We can, for instance, put the saturation to 0. Oh no, I think it's 0 based, so I think -1. And then they are black and white. Okay, so and you can do a lot of things on the operation. So that being said, you don't have only bitmaps. You have other class in Heaps. Just show quickly in H2D. So you have a sprite, which is basically the basic class, so the one that doesn't display anything, which is just a container. And then you have a bitmap. You have anim, which is an animation, which contain, it's like bitmap, but it takes an array of tile. So you create, for instance, a new H2D animation. And here it takes a frames, which is an array of several tiles, and you can put it a speed also, or at which time speed each plays. So just give them the tiles, and it will switch the tiles automatically as the times go. And you have different things such as text, also text support. We have both text class, we can't use this default font for I think the rest default font get. So text file gets a font as an input. So we use bitmap fonts. So bitmap fonts can be exported with different tools. You expect a single texture with all the glyphs inside it, and then you can and then you have an XML file that describes for each letter, each character, the position into the texture. So yeah, there's tools for that to export this format, and then we read at runtime, and we just rebuild all the like buffer with the different small characters together. And that's the way, as every time the text is changed. So when it's not changed, it just keeps the buffer as it. And here I can just take a text to go x rocks. Okay, and I will return because we don't want to. So yeah, it's very little. I will scale it a bit. Yeah, so this is a pixel font by default, and if you look when you scale, you get this very pixel look. So I can actually use what's called smooth to use bilinear filtering on the texture. It doesn't look very nice because things are being cut down to the you see the tiles limit, but well, it's already something. When you use very big texture, you want to zoom and have very smooth. You can activate the bilinear filtering by default. So you have text support. We have also HTML text. When you can do HTML text, we support a few things such as color equal dias. Let's say like this. So when you want to do have a more like complex text with colors, you can put also image into this using image, and you have to say to your HTML text, how do you resolve the path of the source of the image to a tile, and it will insert the tile inside the text flow. So you can, we have a lot of things for text, because for Northgard we need a lot of text for a lot of UI things, so we did build a lot of things for that. We have graphics. Graphics is about drawing things dynamically. I mean, if you're familiar with Flash, we will see it's very similar to what you have in Flash, but here everything is GPU accelerated. So you can draw, for instance, say I'm beginning a fill with, let's stop with the red for now, green. And I can draw a pie. Center will be 500. And ray will be 100, and I will start from 0, and from maybe 3, 4. Let's go to 5. Yeah. Let's go. So I draw this pie like Pac-Man thing. Actually, I should have put yellow. Well, anyway. So you can draw a lot of things here too. We have okay. One thing we have is that unlike Flash. For events like mouse events and everything, we have a very separate class which is called interactive. So basically, all your things you put on the dip list doesn't have any event bound to it. So you need to create an interactive and to add the interactive capacities. So we can do that on the text, for instance. So we create a new interactive here. H2D interactive. Okay. So we need to specify a width and an 8, so I will say text width and text 8, and I'm adding 2 into the animation. This way, or into the HTML text. Sorry, I say called A. It's called BTF for text fill. Okay. So I create an interactive of this size, and I'm putting it into the text field. This way, if I scale the text field, which I do actually, or if I move it around, as an interactive will follow the things, and I just keep having. So in here I can bind direct events like this. So on click equal function hey trace. I can put, for instance, tray fadges color. I can maybe it will go with on over on out. Maybe more interactive. Feels more interactive than clicking on over. There is an event here I can get for getting the relative position and everything. So I can go adjust color, for instance, or let's go with alpha. Alpha equal 0.5, and I on out equal. Let's put it back to normal. Okay. So TF. So, and if I move my mouse over the interactive place, it's become transparent. Okay. All right. That's how all you build things interactive in Haxe, in Heaps.
So the interactivity is related to a section of the screen or to the object of the text?
Because I put it inside the interactive, inside the text field, its parent is a text field. It means it's relative to the text field. So if I move the text field around, it's just. So it's I can show actually the if I want to debug things, I can show the background color. I can put some alpha in there. Let's go with blue. And here I have some this is the bounds of the interactive. So just for debug, to show where it is. So there's something about particles also, which is quite funny, but maybe I will show you later. There's many things about text also, and that's a bit about it.
I was just going to ask, for the text, do device fonts work too, or does it have to be a bitmap font?
It have to be a bitmap file, yeah, for now. But I had support for. I think I haven't played for a long time when you can use create actually the font, because the font is just a collection of tiles. So you can create your own font any way you want. So I had support for what's called native fonts, when you just use a font on the browser and it draws into a canvas and then it draws into a texture. But I found that the quality wasn't very good in terms of rendering for the alpha and things like that. So it was a bit sharp. So, well, I mean, if you maybe I was not using it correctly, but you can call it's called HXD res. I think it's it was font builder, I guess. Font builder get font, yeah, and you can look for instance. Let's try with Verdana in 24. And let's see what you get with this. So I replace the font. Well, it doesn't work, so I have to check out again. But huh? No, it should scale. 24 you mean to 20 is a bit.
You've got to scale 20.
Yeah, you mean it's too big? Maybe something else. I haven't played with it for years literally, so I think maybe that's a problem here. So let's back to the program I had. So Heaps, okay, we didn't do the HashLink part, so I will show you a bit of HashLink. So if I want to do that, the same thing I'm doing right now, so I just control Z a bit. Okay. If I want, let's say you have this example, and you want to run the same thing in HashLink or another target. So sadly, Xdevelop doesn't support yet HashLink integration. So I will just go by command line if that's okay for you. So I go on Haxe Summit directory. I think I have 2 levels. That's it. And then I go Haxe -ashar. Can you read? No, you can't read. I just try to put bigger font. Better? Yeah. So Haxe ashar, let's call it X or summit.ashar because I don't want to write it a lot. And you got lib Heaps and main, or I think there's a CP source and main. Okay, I think that's pretty much it. Okay, and then you run it with ashar summit.ashar. I'll just put no output. Okay, it's an output driver available. So actually, it's rendering the thing and running the whole logic, but it doesn't have any driver to output the thing because we don't use either. We didn't tell it either to use SDL or DirectX. So I will use lib HLDX, which is a HL DirectX library. Compile again, this time with DirectX, and I run it, and we have this window, and you see like we have the interaction working, and well, yeah.
Is there a way to make the interaction area of a different shape?
Yeah, actually on interactive you can kind of kill some. You can first you have a ellipse flag. You can boolean that you can turn to true or false to have a ellipse that follows the box you have been saying, and you can override some function to kind of do your own logic to tell where is the actual area about my thing. Actually, when you go on over or something, I think you can cancel the event, and it's no, it's not for cancel. It's about there's a flag for that. That's just say it's out of the area, and it will continue going through the other interactive if there is any under. So it just you can entirely customize the kind of virtual shape of your thing. If you want to use, for instance, a bitmap, and actually not a GPU bitmap, but a CPU one that you can check for the transparency and pixel by pixel, and look at to see exactly it's the shape, you can use that, for instance. Yeah. Yeah.
Where do we get the HLDX library?
I don't get it. Yeah.
The HLDX library, where do I get it?
The HLDX, yeah, it's not when you HLDX. Maybe I haven't shipped it in one nutshell. Well, you can get the binaries with the HL 1.2, which has been released on HashLink, and for the headers, because you need also the library itself, you need to check out GitHub. Right now, you need to check out GitHub. I think I would just put it on after the conference on XLib. That will be much more easy. Yeah. So you have HLDX and you have HL SDL, because right now you can put it. They are in the HashLink sources. Okay, so they are part of the sources. So we compile with HLDX, and we can use instead HL SDL, which is an entirely different library using OpenGL and SDL, and I can run it. Well, it's pretty much the same. You have to trust me on this. That's an entirely different rendering. Okay. Any questions so far? More questions? Yeah.
On Mac, I'm trying the sample one. Is the HL OpenAL up yet?
Yeah, it's the same thing. It's on the hash. It's you have three libraries actually. There's a one for sound also, and they depends on the they both HLDX and HLDL both depends on HL OpenAL. And the three libraries I will release them. You can, if you want to use it right now, before waiting me to go to come back to the conference, you can use xlib dev using the same directory by checking out the HashLink sources. So
I checked out the sources.
yeah, you check out the HashLink sources, then you go on the directory, libraries, and etc. And you, I think if I don't have it there, but it's no, they are installed some other place. So. Okay. Anyway, let's go to more advanced things maybe, because it's unless you have more questions, yeah.
Can you show text input also?
Yeah, sure.
How much features like copy paste?
Yeah, I have. I think I have all of them. So we translate this into a text input. Okay. So it's the same, it's just the text input, no. And I can. Okay, I put an interactive on top of it, so it's not going to work very well. So, okay, get rid of it. So, and I have a cursor, I can move around. I can select things with shift, backspace. I can use a mouse to select things around. And I can maximize, well, it's pretty much.
Delete?
Huh?
Delete?
Yeah, delete, yeah. Control, copy paste. Copy paste is not yet that. I think I don't have yet the cross-platform clipboard support, but. Or maybe I did and it's not yet in, I know, I can't copy paste right now, but yeah, that's only thing missing. Not very hard to get that. I need to work on it, yeah. So but there is more mouse support and both keyboard with arrows and everything. And I think there is also home and I mean the things that's not so much used, but Yeah.
Should that interactive thing be considered a child of the text field, like in a flash sense, or does that concept not really exist in your API?
Yeah, it's a child. Yeah, it's part of the display list somehow. Yeah,
Okay.
and because you can show its background, so it's part of the display list. Yep.
The carrot seems a bit off for me. Like,
Yeah, because the text input is not an HTML text. So you cannot have a text input with HTML so far.
no, I mean look at this. That's like a bit lower.
Ah, it's a bit lower. Yeah.
It's fine for you, but for me, I don't.
Okay. Okay. Well, maybe the text. Yeah. Well, we'll see. I will check that afterwards. That's a live bug report. I love this. Okay. No more questions so far? Okay, let's move forward. How much time do we have? 1 hour. Okay, we just okay. This is done. Tell me if not done. Acting APIs to SDL. Is it already partly done?
3D.
Yeah, 3D. Okay, so we go 3D. Yeah, let's go 3D. Yeah. So 3D. Just we replace H2D by H3D, and it works. Not so simple, but anyway. So in H3D you have different things. You have a H3D object, which is a kind of H3D scene object, which is the basic container. Doesn't do anything, but still there. And you have the most important is actually the mesh. I just clean up the code. So the mesh. A mesh in HL is something that can actually display something in 3D. It takes 3 arguments. The first is a primitive, which is actually what kind of data you want to display. The second argument is a material, so what kind of texture, for instance, or what kind of display you want to have. And the third argument is a parent, which is always like a where do I put this. So I will create a simple primitive, which is a cube. H3D prim cube, okay. 1 by 1 by 1 should be okay. Then I put it into as a primitive, and I add it to the parent is S3D. So I put the mesh into the scene, and that's it.
Material?
It's optional. It's a cube, okay. Quite easy, isn't it? Now I will just modify the material to material, so I can modify a little the material. It's created by default, and I can enable the no, it's the main path. I will enable the lights on it, and so it's more light than before, but it still doesn't have this now, directional, because I need to add a light to the scene. So I will add a light, directional light. I need to write the direction, so I see this. I will create a vector, which is a direction. Okay, I study vector. I go from the little bit on the right, left up, and to the bottom. So Z negative. Okay, these are just 3 coordinates for the direction, and I do that to the scene as well. And it's not working. Why? The delight. What's going on? Maybe it's beginning to like this. I know. I need to add normals, and I have some exceptions, but it's showing in the consoles. What we add, I will add more UVs. I will just manipulate a bit my primitive. Okay, I index the things. Okay, well, that's pretty much it. Yep. So I add normals, data, and texture coordinates for the cube. So here it is. And we can move the light around, for instance, show you 3 time. Which stores it's a parameter here. I don't know if we do, maybe we should move the cube around. Maybe just rotate the obj, maybe it's better. Let's put the lights here, obj is there. Okay. So a mesh is an object, so it's a mesh, and it's a it's a subclass of everything is a subclass of objects in a 3D display list. And I will just do a rotate. Rotate. I will rotate on 3 direction. So 1 pi dt. Well, it's maybe fit fast. Let's go slow rotation. There's 1, 0, 0, 2, 3, and 0.05. Okay, let's go with this. So we rotate in 3 directions like this. Okay. So I just keep rotating in all those places and getting the lights showing. That's not a very nice rotation actually, which what we want maybe is more just more beautiful. Yeah. So a cube, as you see, that axis is not centered, so you can actually do that by translating our cube here. Translate by, so you have a cube by 1 by 1 by 1, so you can translate by 0.5 minus to center it a bit. So the pivot, because the pivot is a mesh, it's not the cube primitive itself. And it rotates nicely. Okay, then we can add textures. Yeah.
Can you explain what line 7 to 9 do?
What's light?
7, 8, and 9.
7. Light 7, 8, and 9. Oh, the line 7. Okay, the lines. Okay, it's okay. So 7 means unindex. Okay, I can show you without unindex first. Okay. Basically, you have a primitive cube. Okay, and a primitive is just coordinates. It's called vertex. What you call vertex is a single point in space with different informations in it. So what we want to add at first when you create a cube, you just have the position 3D. If you want to add lighting on it, you need normals. Normals is the information per vertex that tells you where the face is facing and how it will react to the light. So if you add normals to a cube, it can get the lights. The third one is UV. UV is about texture coordinates. It gives for each point where in the texture this point relates, which means when you have the 3 texture coordinates, it maps the texture to the triangle. Well, I mean, you see. And unindex is about, you know, if I do like this way, I will have a very smooth cube because each vertex is shared between the different face. So the normals will face out in diagonals like this. And if I unindex first, I will split the vertex at the corners into unique vertices for each face. So we'll have one vertex for the front face and the same vertex, another vertex at the same position for the top face, but there will be 2 different vertices between one can have the normal goes up and the other one can have the mouse go to the left. So well, it's just, you don't do that on a regular project, to be honest. Just usually the graphics people already have built the assets, which I will just show you just right now, and they give you the assets, so you don't have to manipulate the kind of vertices the way I'm doing now. It's just more about building them this way. Other questions? Yeah?
With things like render texture, it's automatically added to the stage. Can you render the 2D on 3D and that sort of stuff?
Yeah, you can actually 2D is always rendering on top of 3D, and you can, there is ways to go the other way. Yeah. So let's go. I'll go faster because there are a lot of things I want to show you and we have little time. I will then have the texture. So obj.material.texture equal. So you can use the same system that we have here. We go the X logo and we do 2 textures this time because it's expected texture, and that's it. And we have our cube mapped with texture. Okay. That's pretty easy, right? Well, it's nothing fancy, but well. And we can have, of course, a lot of cubes and everything. But I want to show you also like actual models. So I will get a model from the Heaps sample again. Like this, you can find them back at home. Here, for instance. And I copy them here. Actually, I'd open 2 things, but anyway. Res. So here I copy 3 files. Actually 2, 1 is missing. Okay, I will open two because I want to go and block. Heaps, samples. Okay, this one. Okay. So I have added 3 files. One is a FBX file. FBX file is a very standard 3D file, 3D model file. We're using FBX text mode, which you have to be aware of when you're exporting for 3D software. And you can look at it looks like a bunch of some kind of JSON or something, with lot of numbers inside it, and we process it into if it's been modified since last time, we process it into what we call a HMD file, which is our internal format for 3D stuff, and which is a lot faster to load. So FBX file is only the kind of format your graphics people will export to, and then what you ship in your game are actually actual HMD file that gets more compact and binary version. Okay, and the texture, of course, that goes with it. So here I will just, instead of let's forget about the cube, I will go to my texture loader, and you see I have this different thing. So I have my model here. So I can do 2 HMD. Oh, actually I don't do that. Okay, I will just do. I create first a cache. Cache is a way to store your models. You want to reuse them as you go. You don't want to load the resource every time. So you create a first, I think it was a prim model cache, yep. And then you do cache load model, and you pass it your resource, which is actually model. It's my resource. And then I think I get an object directly out of it, because actually when you load a model, it's not a primitive. It can be several objects already structured. So in our case, you will see it's actually quite a lot of things. Compiles. Those compiles. I guess it's processing the HashLink. Why it takes so much time? I have no idea. What's this? No. I don't know what this is. Okay, you say H3D object should be a mesh, because what we return, I say, is the set of objects, and we might have a root, which is not sure it's a mesh, so it's an object. Let's forget about the cube for now. So, because we just create the objects, it's not yet added on the scene, so we do S3D add child obj. So we add this object to the scene. It compiles. It takes a while to compile. I don't know why. Oh, I think it's an embed thing. Maybe. Maybe we can switch to HL if it's just seems strange. Okay. So it's really big right now, so we have to kind of scale it down a bit. Yeah, I think it's X4. Scale it down a bit, compile. Okay, it's better now. So here you can see our model showing this skeleton. I will put it. Okay, I will move the camera, because it's in 3D, so you have a camera actually, and you can move the camera around without moving your objects. So the camera is located in the s3d.camera class. So I can move for instance, we are far, so we want to go there. So it's the Y, I think. Position Y. Plus equal to, well, just trying to. Well, you know what? Let's go further. We can add something which is called a Cannula Controller to the scene. It's something which quite handy when you want to display things. It's actually scene Cannula Controller. We add it to the scene this way. And like this, we can actually zoom. Okay, one instance. and I think that's load from camera. Yeah, I have to load the presets, or the presets are reset by default. Okay, and this way I can actually move around, zoom, pinch, and I can rotate, but it's rotating on itself. I will just stop the rotation from now. Okay. So yeah, so I can play with it and just show and zoom and pan. I can look around and do these things. So here the skeleton is getting some nice shadows for the shadow engine of the game, of the engine. So you can see it has these self shadows. It doesn't show very well because it's not playing any kind of animation. But this FBX has some animation actually embedded into it, so you can load it. So you call load animation. So because so far we only load the model, the 3D model. So we just load the animation, which is also in the same resources, and then we play it. So we just do play animation, anime. Okay. So you can play the same animation with different models because it's the same data, and start working, and you can see in real time the shadows are showing on the.
Background color difference, not so great on the projector.
Yeah. Okay. Background color, engine. I see engine. Engine, background color, and color. I'll try to light it maybe this way. Better? Yeah. So you have self shadow. I think the light is not in the right direction somehow, because we don't have a light actually. That's why. I remove it. Directional light. Let's put it up. This way it's just light going down this way. Okay, so you have just the light going up and shading the thing. And well, you see the self. If I zoom in on the end of the, it's a very low poly model because I didn't want to add high poly ones. You can see the shade is very safe projecting on things, so it's real-time shadows. And well, there is some things not working well because it has this transparency on some parts of the model. But it should move out. But it can be enabled by changing the materials properties and everything. So well, just a small example about the workflow. So the workflow is about exporting models, loading them at runtime, playing animations. And that's it. That's how you build a 3D game. Is there some other questions related to that? Yeah?
Yeah, what tools are used to create models? I mean,
Yeah, so we use professional tools. So you can use 3ds Max, Blender, Maya, everything that talks to FBX. We've been mainly testing Maya and 3ds Max at work. So maybe there might be some issue with Blender. In case you can report me, but I think it should be okay, quite easily to adapt because FBX format is quite flexible. So depending on the export source, it might differ a little bit, but well, it's easy to change and that should work.
I was
Yeah.
going to ask about BPS. Are you planning to have BPS?
What is it?
You know, like when you upload a building and you say, and then the man can walk around the building.
Oh yeah, no plans for that. Yeah. Okay.
What about the situation when you have like multiple animations on your
Okay, you have a way to actually animation just some like data about frames and positions and rotations, and we have something which called transitions. So you can create actually you can create things that mix animations together. So you have things for this. For instance, when we start a new animation, you can choose to use a transition to switch to another animation to make it smooth, so it doesn't kind of change the pose. So we have this already in the engine, and we are working on more tooling because when you want more complex things, it requires some kind of middleware to be able to, select which part of the animation you want to play and which part you not. Everything is possible from code right now using the correct. You just have to extend animation and have 2 sub animations and mix the things by your own factors. But we don't have yet the middleware to edit this. That's something we are working on right now to really have some tools for that. Yeah.
how do you dispose the bitmap data and stuff?
Okay, so there are several ways you can dispose things. One way is just manually by going, for instance, going to the primitive and using manual dispose on it. On the texture also, you can use manual dispose on it. And there is for textures, there is a automatic, and for most of the models, usually they don't take so much space on the GPU. What is heavy are the textures. The models themselves, they are not so much heavy. So for the model, when you use a cache like this, you can dispose the whole cache if you're done with it, or you keep reusing it. And for the texture, what we do is that we tag the texture every time it's used. And if after, when we allocate new texture, if we are a little, depending on the various reasons, if you want to kind of garbage a texture, we just discard the old ones that have been used for some time. And the ones that actually comes from resources, because we know that in case they get used again, we can actually reallocate them, reload them from the resources, and get them back. So, for instance, when you have a resources that is loaded from resources, like I said, like the HashLink logo before, it's tied to the texture is tied to resources. So, if in case we dispose it, if we want to reuse it later, it's disposed, but we can reload it from the resource and put it back to the GPU if you want. So it's automatic, it's done in the background. So this way we allow to garbage the texture that are no longer used for sometimes, but in case you use it again, they will get back. But you can still manually dispose if you want.
What do you mean to reload it from resource? Is it stored in some kind of cache?
No, I mean like the resource, because the resource is your resource loader. If is supposed to maintain some cache, or maybe you don't want to maintain some cache. If you want to, if it's loading into memory, usually we work with file systems, so it means reading it back from the hardware. But if you want to load it from the network, then you might have to reload from the network to put it back on the GPU. But I mean that's depending on what you have as a custom file system. Yeah. Yeah.
You're loading you're accessing your HXD REST model tries. Does it mean it's processed in some way tries, or how does it work? Because you have an load model and load animation.
So what I'm doing is that it's in the background, the resource system, when you try to load at runtime or at compile time, depending what kind of, for instance, here we use init embed. So it means we need to compile all the resources at compile time to embed them into JavaScript. So it means it will go through all the FBX files and it will compile them to the HMD file as we have here, model HMD, which is a like binary version of the model HX here. And it will link this one. So, and when it's not done using a local file system, it will do it at runtime. So if you load a resources, a FBX file, and it's been modified against the HMD version, or if the HMD version doesn't exist, it will compile it to a HMD, then load the HMD. Yeah. So, yeah. Answer the question? Yeah.
Yeah, just wasn't sure if it's going to process the try somehow, because you access the same thing using different methods.
Oh, and this here, when I'm doing load animation, it will cache first the HMD file, then build an object on it. So if I do several times load model, the first time cache pass the HMD, then build the object, and the second call will only build the objects layer. So it just, you can call it several times. The first time is cost, and the other times is faster. Same for animation. Yeah. Yeah.
Can you replace parts of textures on those models?
Yeah, sure. Yeah, you can access the whole tree.
So like play a video on chess or something like that.
Playing a video, you can have a video and upload it to a texture in real time, and then just replace the texture. Yeah, it's possible.
So you'd be able to map just to the named part.
Yeah, you create a video like a texture. You can create a texture by hand by using a new H3D material texture, and the width and the height. Or you just create a texture, and then you put it into the material. You replace the one that comes, and you change it, and that's it. Yeah. And I maybe show more questions. No, I think we okay. So I will just move forward with it because still a lot of things to show you. This is just the beginning. So here, so you have control. Send preview. So yeah, I'll show you a bit some tools. Tooling is important. So this is something I just started maybe, I think just in June or something. So it's just very, very early. And I work only a few days on this, but this is based on the Node WebKit. So it uses a panel system, and you have plugins for different views for your project. So here you can see this is Northgard. So you can see all the resources we have in our project. So you can create open files from here. For instance, here I have the beer, which is in the monster beer 01 that sits here, model FBX, and it shows here, so I can look at it, look it around, and I can disable the lighting to see it different ways. Here as an object, so when I load the bear, actually, I have an object called root, which is just a plain object. And inside it, I have a skin model called bear01, and this is a material. Here, when I can see the texture, I can right-click to view the texture here. So this is a bear texture. It's used to map the texture thing. So if you're not familiar with 3D, it maybe looks funny, but that's the way it works. And I want to close this, not working, still alpha. And I have the animations here, so I can actually select different animation we have, and there is a timeline at the bottom, so you can see all the animations they have, and you can see, for instance, here I have events. I'm not showing very well. I can go. There is events on the timeline showing when the thing, and I can play the animation manually like this if I want to see exactly what it's doing in slow motion. So, and so yeah, that's the middleware we are working on. And one important thing for us, because every time we build a game, we create really a custom engine for it, because we think that's a good way for us to be able to kind of customize the rendering depending on our gameplay and our technical objectives. So we wanted to be able to really have really custom materials per game, and that's not easy to do, because usually when you use like Unity or Unreal, it comes in with their own material system, and it's difficult to replace. So what I did is that I actually expose some kind of scripting abilities when you have a single file that somehow describe materials for your game and the way they have to be displayed. So right now I only work on the description. I have not yet finished the kind of display part, but the goal is to be able to get into the IDE exactly the same rendering process that you will have in the game. So the artists, they can preview the assets in the same way that they will see in the game, and they can control like the material here. For instance, this is custom material here. They can have, for instance, this kind of late alpha, which is something very specific to our Northgard engine that can toggle and see how it affects the rendering. So, and they can reset the default, because using a lot of by naming conventions for our materials. So it means our artists, they don't have to set up all the materials for every model they do. So for instance, by default, if they use a PNG, it will be use transparency, but sometimes they want to use a PNG and not transparency. So, well, for different reasons. So they can here, for instance, they can use, for instance, there is two modes of alpha also. There is a full blending alpha, and there is alpha kill, which is just kill the pixel, which are alpha 0, which is really different in terms of performances. So they can adjust this based on your engine. So it's something quite, I want it to be quite customizable. And we have also a particle system editor, which we are working on it. It's broken here. So particle system editor is quite fun to work with. You can have different particles emitters inside one scene. I can zoom in and just scroll down a bit. Can I do that? yeah, I have to control. Is it? Oh yeah, no, it's just pan. Yeah, yeah. So this is a fire. I just zoom in to show you how it's done. So this is a fire made on several emitters. So you have the fire, the smoke, and the sparkle, and each of them have different things. And I don't know why it's broken on my build here, but you can adjust the amount of particles in real time. Like you can specify the angle of your emitter and see how it emits. You can tell the distance at which it emits to emit on a given distance. You can toggle the life of the particle to make them, have a very long life or very short life. So you have a lot of properties you can modify to create your particles, and this all gets saved into a JSON file that can be loaded in the engine and play again. So that's kind of things we are working on. Yeah. Any question? No? So we have both 3D and 2D particle system editor this way. So you can create particles for 2D as well. What else? Yeah, this you can also edit JSON on JavaScript like in the editor, which some say helpful. Yeah, CDB. CDB. It's another tool we are using for our gameplay data, and I've been showing a bit before this. So it's been moving quite a lot. So when you create games, there's a lot of data to process. There's graphics data, but there's also gameplay data. Gameplay data are about the list of units of items or quests, anything in the world. So this is actual data from Northgard, where we describe different resources in the game. So you have like a name, which is a unique ID. You have the ID is actually here. The name is here. Sometimes it's not exactly the same as the ID. For instance, the money, what we call money in the game is called crowns in Northgard. And actually it can be translated to other language, so the name might vary depending on the language you're being in. You have description, and you have some properties that you can have for instance, automatic conversions to another resource or this. And the idea is that you can create, I will show you from scratch because it's much more interesting. You can create a new cheat. So it's based on a cheat. So let's say, okay, item. I don't think I have item thing. And so you just create columns. So first I will create an ID for this item, which is a unique identifier here. Then I can insert line and say, okay, this is my sword, and this is my what do I insert here, and this is my my shield. Okay, and if for instance if I insert, because it's unique, if I insert a second shield because I'm not careful, it will say duplicate. Okay, and just warn you about duplication. And I can add another column. For instance, how much this costs, and it is an integer, for instance, or let's say more things. Let's say it costs something like in terms of resource. So I can reference another sheet here, which is a funny part about CastleDB. So I say that the sword costs actually some fame, and the shield actually costs some money. So you can bind the resource together, like, and they can kind of like it a lot. So just to be clear, that the world data here is just entirely created for Northgard, but the ID itself, CastleDB itself, has no idea about anything specific about Northgard or anything. So everything is generated based on the models, data models you're doing. So it's really generic. We use the same for different projects. And here, for instance, I have the list of buildings, which I can have, like, for instance, is the cost. When I have a sublist of resources and costs, and I can have like different properties here about the value, like, about different descriptions, and I create more properties. So yeah, you have really like you can have flags when you just double click and describe the flags, and you can just check them. Here is described here. This is a colon flag, so if I edit here, I can see this is the type flags, and you have the list of flags that are available. And of course, nice part is that because of macros, your whole data model is available directly in your game without any thing to write. So the whole data structures that you define here and the whole IDs you have here are available in your game at compilation and as strictly typed. So if I can reference house as an identifier in my game, and if I change into the CastleDB and I recompile, I get an error. So, and I can access the properties or everything, all this data I can access into my game like in real time. So if I mean, that's yeah.
Is it possible to load data at runtime?
Yeah, you can load data at runtime, but you have to compile with the data model. And if the data you load at runtime has a different data model, for instance, you have modified the data model, it will not be able to detect errors right now. So you have to make sure that you can, for instance, let's say you have a data model for items, and you have 10 items inside. If the data you load has the same structure, but have 20 items, no problem. You have just, in your list, you'll have 20 items, and it's okay. So it's not a problem. But if you had a different structure, if you change the way the cost is represented into the data model, then it's great for them. So you have to make sure about, yeah.
Do you put translations into it?
No, we don't put translation. For translation, we tag the text as being localized. For instance, the description here is a text, and you check it as localized, okay? And then you can export an XML here, which is export localized text. It's export an XML with all the localized text for your data, and you can actually get it translated and get it back, and then you can actually load your data model, and then you can patch it with the XML that's been translated. And the way it works is that in case you miss something, it prints you, but it doesn't bug, so it keeps the original text. So this way in Northgard, when you make an update, if we don't have finished the Chinese translation, it will fall back to English for this specific text. So it's a good way for us to keep going without having to wait all the translation to come through. Yeah.
What does it actually generate for CastleDB?
CastleDB is a big JSON file.
Okay.
Yeah, you have both in the CastleDB file. You have both a JSON about the structure, so all the description of the different structures, and then you have data. And data is pretty much what you will expect for if you have written JSON yourself. So it's not like kind of magic inside.
That JSON with a macro, or at
Yeah.
runtime, depending on what you want.
Yeah, you can. We do both actually. At compilation, you use the macros to load the data only for the structures, to generate all the structures, and to generate all the abstracts for the type, for the unique ID. And at runtime, we load the whole thing. I can show you maybe quickly. It's maybe out of the scope of this talk, but yeah.
How many rows do you support in a single sheet in CastleDB? Thousands? Or?
I mean, I think thousands will be maybe difficult to work with. More about,
Yep.
Yeah, that's more. I mean, this is just this is an HTML application using Chrome rendering. So I mean, as long as the Chrome managed to display it, should be fine. Yeah. Okay. Yep.
Well, I assume you work in a team, and one of the game designers is working on
Yeah.
this.
Yeah.
Does it commit?
Yeah. Because it's JSON, it can actually merge quite well, so you can get a full history of change. You can work on different parts of the data, like different people, because it's JSON with it's JSON with space and new lines. So the only problem we have is that if we add both a new thing at the end of the list, you get some conflicts. But most of the car, and actually we could have some scripts, merge scripts to handle this case. But most of the case for JSON data kind of merge pretty well in terms of. It's a good thing of having text representation. Yeah.
I'm actually using that, and I'm using it, 2D map feature.
Uh-huh.
It would be cool if it was also possible to specify like a sprite animation.
Yeah. Send me a pull request.
You just said it's like HTML application, but it does look like native one. Do you use like Electron or?
No, I'm using not WebKit. It called not WebKit. Yeah, not WebKit. NWJS called.
You're not using Haxe for like.
Oh, it's written. It's entirely written in Haxe, of course. Come on. Yeah.
I'm wondering why did you take this approach with defining structures through the UI instead of defining types in the code and then generating.
Yeah, I agree. When I did the database before, I went from the code to database because you had to write requests on the database or something. But I think having it more visual is more appealing to game designers because they can kind of start adding things before you add it to the code. And I mean, I'm fine with both personally. I can define my structure in both code or visually and try, for instance, when you start working on something, you can add things here. I mean, just a preference, and I think it works better for us this way. Yep.
A potential future pull request is my designers work with spreadsheets, and there are so many columns that are almost empty.
Mm-hmm.
There's just one thing with
Yeah.
no value.
Yeah.
And the ability to say hi to all the columns.
Yeah, that's what we have already here.
You already have it.
Yeah, it's here. It's called properties here. For instance, edit here. It's a type properties. So type properties, you see some of them have no properties at all, and some of them has 4 or 5 of them, and you can have many. So it's a kind of optional thing you can have. So if here you have no properties at all, and I can choose one of the properties that is already default, create, or I can create new properties. And new properties will be like kind of selectable for all the history type it, so it's not like a dynamic. And if you really want dynamic, you can create dynamic things and input JSON data. Oh, so it's still possible to write dynamic things into CastleDB.
Is that a sub-object or these fields are merged into the?
Yeah, it's a sub-object. It's just the data as you will write as you will have written it. It's just pretty much what you will expect for.
But can you like hide a column even though it exists in JSON?
Hide a column if no exists in JSON. Not yet. Yeah, no. I mean, it will get lost if you load and save. Yeah.
Can you show how you access the data?
Sure. So, how I go? I will just copy I guess this file from now, data.cdb, to our resource directory here. So it's like 147K, so it's not very big. Just showing you how it looks quickly. I think we still have a bit of time too. So it's just, here you have this first part, which is the sheets, which is all the structures and everything. And for each of the sheets, you have name columns, different columns, and then you have the lines. And the lines is really what you will expect. So you say ID food, name food. Graphics, it is a graphics with a X and Y position because it's a tile, so it's a part of a texture. And the properties that we saw earlier. So yeah, it's pretty much a lot of things you can have here. So from the code perspective, is here. First, it's based on things. So we just create a data, and I will copy it because I always forget how to write it exactly. You just have a single file to put in your code to trigger the macro. Here. Okay, I don't need that. It's just more thing. And it's just a type def init equal x macro type, which is a way to build a module. And you just say CDB module build. This is a macro specific thing, and you pass it the file data CDB. Okay, that's how it works. Okay, so.
And if you want to use it at runtime, what would you change?
Okay, you will see. Like this is just for the compile time for now. So and I just start doing here. I can do. Let's try to import it first to check it compiles correctly. Import data. And it's saying type not found CDB number because I haven't linked the library. So I need because CastleDB is not part of Heaps actually. It's another. I just wanted to use the tools, but it's a lib castle, which you can get on Xlib as well. Maybe not up to date, but yeah. And oh, of course, duplicate 3 declaration shield because I have 2 shields. I will just maybe remove some JSON for now. That's me for making tests. Let's check shield. Yeah, shield. Shield wall, shield maiden. Of course, I have a lot of shield in Northgard. And I could just go with shield, try 2, shield 2, okay? Shield 2, okay. Usually it just shouldn't happen compilation because it's, yep. So it compiles. And now you need to load the data because here we have just the data model, but we don't have yet the data itself. So after we embed our resources, we can do data load, and we need to pass it a string, which is content. So we use our resource here to do this. This is just, so I think maybe 2 entry to get text, I think. Get text, yeah, okay. So we read this file from the resources and get the text and load it into our data model. So here we have a data load, everything happy, okay. Now how do we access this? Well, you have a bunch of classes that are created for you once per sheet you have created on the CastleDB. So for instance, I can go to the items I created before. So I have data item all. I can trace I can try dot. You see, I have the ID, so I can, for instance, switch on i.id, and I do case sword, and I do something, okay? And if I compose, it will complain about missing shield and shield 2 handling, okay? Got it? So that's really you already have all the things, and at runtime it works. So I had the default, and I can just trace i.cost.name. So I just try the name of the cost resources that I bound thing. Okay, and I just run, and if it's shown in the console, I guess fame. Okay. Oh, okay, like it. Okay, let's back maybe on Heaps a bit. Let's back on the. I think I close. Yeah, that's what it's. Send preview. I think we saw it in the. Tell me if I'm wrong. Eh? Send preview. We saw it into the hide project, which allows you to preview like your assets and everything. Animations are playing also well. HTML targets. We show WebGL targets. Runtime loading. We haven't looked much at it. Basically, it's about preloading your resources using things. I can show you. Well, one way to do that is to, for instance, to load using traditional JavaScript API, and for instance, just have an embed. Just first load a quick file. Is really easy to load with just a few assets for the loading screen or something, and then you start loading more files as you go. So the thing you do is like to use. It's pretty complex, but you will go HashLink init. You will just have to create a custom file system with a pack file system, what I call. So it's a new HXD file system. Pack. No, it's actually it's format pack file system. So this is a pack file system. It's just a file system which at the base of the resource management that allows you to load different things, and you can add in several paths. You can add pack files, which is just a file input which can be in memory or on drive or whatever. And so what you go is you would just first have one specific file, maybe Embed, or just you load it first in JavaScript and then you put it there. Then you add the pack. Then you can actually start loading more files as you go. Or you can actually have your own, if it's not about packet files, packets of all files tied together. If you want to load texture by texture or model by model, it requires a more custom file system for you. I haven't done this yet because basically you need at some point to be able to modify the models and everything to be able to handle them correctly. It's difficult to do that without having to load, without having loading the resources first. So the Heaps is less async design, more synchronized design. So first you need to load the resource and then use them. And you cannot it's not based on, how we load a model and then I can wait for something until it's finished. So it's more, first I load the resource, I put into my system and I can then create a model for it, just this way. So yeah, I can't really show asynchronous loading. Is more complex than that to put into thing. 3D Object XB support with that. HXSL. Okay, let's do a bit of shaders and networking. Then after that, we have 30 minutes. Oh, perfect. 5-7 minutes for each of them. So, shaders. I think I got it back to 2D. Or maybe not 3D is fine. 3D is funny. Yeah, 3D is funny. I will just go back and remove that. Get that. Okay. So, who doesn't know at all what is a shader? Who doesn't know at all what is a shader in 3D? Nobody? You know what is a shader? Oh, that's cool. So, I will just jump forward. So, you can define your own shader in Heaps using a simple class, let's say Summit shader, which extends HXSL shader, which is a base class for a lot of things. And then you put your source code into a static variable source, which will be processed by macro. So between these two braces, we are no longer we're still writing X syntax, but we are actually, this X code will be compiled to a shader, okay? So for instance, I can use these things. I can import keyboard. I can import using arrowbars, using metadata, H3D shader base 3D, base mesh, sorry, which give me all the definitions about what is available in terms of property from for mesh, because I can have shader for 2D or shader for 3D. So it's basically, it means this shader will be applied to a mesh, to the 3D mesh, not a 2D thing. And then I can, for instance, have a vertex shader that does something. So let's say, for instance, what can we do? We can do a relative, well, I think, well, I have to look at this to see what is defined to make sure I have. So the base mesh defines a lot of things here. You can see you have input, you have some globals, you have control on the camera, you have output, position, color, you have different transform thing, pixel color, and well, a lot of things you can access and actually modify. And this is more about default implementation that can override in your shaders. So what is really particular about HXSL shaders against, a normal shader, when you write shader in GLSL or DirectX, you just have to write all of it. You just have to write a vertex shader and a pixel shader and everything. I mean, so separate them, but they have to be quite tight together. And what is specific about HashLink, about HXSL, HX shader language. Yeah, sorry, too much acronyms here. I'm getting tired. About HXSL is that you create bits of shader, some shader parts that gets compiled and linked together at runtime. So you have to think of the shaders in this concept, in this context, as kind of effects that you get applied together to construct your final shader. Okay, so basically when you have a mesh, it already has this base shader applied, and what you want to do is modify what it does to do additional things, or to do it differently. So for instance here we use something relative position .y plus equal relative position, or .z plus equal relative position .y minus 0, 1. Okay, so what it does is that we will change the position of the vertex because it's in the vertex shader. So each point of our geometry will be changed its z position based on the y position minus or multiply 0, 1. So we will actually kind of modify the geometry at runtime. Okay, and so here we have the shader, very simple one. It doesn't do something very interesting, but just to show you. And we need to apply the shader. So to apply the shader, we need to apply it to the mesh. So what do I do? Insert mode. Okay. Yeah. So I go for M into my OBJ. So I get all the mesh that I have into, or actually I can do maybe better. I will get all the materials that I have into my object, because you have a tree of objects with different mesh, and this mesh might have different materials, several of them sometimes. So I get all the materials, and for the main pass I will add a shader, which is our new summit shader, and that's it. Okay, so I add the shader to the mesh. It means that I got this thing. We can't see much of it, to be honest. Maybe let's try it on the transform position. Okay, I'm in set mode. How do I take? I don't use this computer a lot, so transform.
Maybe a fragment shader will be more obvious.
Yeah, it will be. That's right. Let's go with fragment. Okay, you're right. No, I don't have auto-completion for the shaders yet. So for the shader, for instance, I can say output.color equal vec4 vec4. Hey, come on. Vec4 1 0 0 1, which means that I turn the whole color into red. Okay, so this is a shadow that's really does something interesting, but I can do also, dot red equals 0. So I modify the output color red channel. 0 point, it's a bit tricky. And okay, 5 minutes. So it means I have removed the red channel from my shader, and so from my model. So you can do a lot of things, and you can actually apply a matrix to kind of transform the colors the way you want, or you can do like even apply the red, multiply by transform position dot z. So you can actually change the red color based on the z of the model. Where it gone? Where did you go? I close. Okay. Misclick.
How do we assign the shader to the material again?
Let me check. Yeah. Main pass. You go on main pass. Because the engine is based on multipass, so you can have multipass rendering, which allows you to do some fancy stuff. And so here I do depending on the Z of the, so you can see at the bottom we just remove the red, and at the top we don't remove at all. So actually we increase the red, I guess, at the top, because it's larger than 1 unit, 1 meter or something. So yeah, and you can do a lot of things. So, and for the fragment shader, I want to show you, or you can manipulate the geometry, but transform position dot x 2 times. Oh yeah, that's it. got a bit fat, you know. That's actually, yeah. And you can actually have something more funny. Equal sinus of auto completion. Let's bring at the transform position dot y for multiply by 0.2 5 plus global dot time multiply by 2 plus equal multiply by 0.5 0.5 and let's do plus equal. Okay, that's gonna be fun. Transform position. So this wall, like you see, is kind of oscillating, and maybe not exactly what I wanted to get. I think I should put more things here. 3 and more time. Global times y 0 4. Yeah, that's more like it. Okay, so all the calculus, all the like sinus and calculation is done on the GPU, so it's really CPU free, and you can get really like easily like kind of this kind of transform that's kind of very weird but very funny to play with. So if you are into creative writing, creative programming, it's a lot of fun to do. So yeah, I think that's about it. I think we didn't see the network part, so I will write. Yeah.
So if you add several shaders to one part,
Yeah.
they are concatenated.
Yeah. I can. I just show you one last thing. I can have this shader and split into 2 shaders, one with a vertex and one with just the fragment, for instance, or additional vertex, and the transformation piles up. So you can add 2 shaders or 3 shaders or 10 shaders to a thing, and they all get compiled and optimized into a single shader at runtime. Okay? Yeah?
What are the rules for importing in the shader context?
Yeah, just you can import a definition, and you can just do either import this, and then you get this definition, which you can override, or you can extend a given shader, in which case you cannot override or something. It's a bit.
You cannot import arbitrary variables from your own function, for example.
Yeah, you can have a library, for instance. Let's say you have a library here, and you can say my library, which have all definitions and functions, and you can import them into your thing. Other questions?
Yes. Can you use it to make a complex floating point calculation on the GPU?
There is no, right now in Heaps, GPU compute support. So it means you can do all the calculation on the GPU using shaders, but then they get output to some texture or something. So it's not really easy yet. I'm planning to do that. Maybe 1 or 2 years will take more to have more like GPU support, when you can have a shader that does some calculations and output to actual buffer that you can read back to the CPU. But it's not, not my. It's interesting, but not my focus right at the moment. Yeah. So, well. So I think that gives you a good understanding of things you can do with HashL. Just to show you, like, I don't know if I have Steam here. No, maybe no. Well, you can look at the kind of game we are making, like for instance, Northgard is entirely written in X 100% using this framework, Heaps, and running on top of HashLink. So you can really get quite a good amount of visual quality. Of course, it depends on at some point on your game artist. I'm not the one doing the graphics, so you need some kind of good artistic direction. But technically, we have everything we need to build this kind of game. And that's all for now. So if you have any questions about it, more questions? No? Yeah?
Does it work on mobiles?
On mobiles, I haven't, to be honest, I haven't played with it very. We have one mobile game we've been working on for some time, but haven't much, and it's using Heaps with air. So you can use Heaps, and it's not air like the slow air. It's because it stays 3D, so it's using the 3D API on the GPU inside the mobile. So it works well, and the thing is that you have all the tools for code signing and publishing other applications with air. But yeah, if we wanted to get serious about mobile development, maybe we would make sure that HashLink compiles and run on mobile. I guess that's not very difficult to do because HashLink is pure C code. So if I was able to run it on PlayStation with just a few changes, so I guess on mobile it should be even easier. Get it compiled correctly. SDL I think is available on mobile. It's OpenGL. So once you have HashLink, compile it to C and running on mobile, then you pretty much have all Heaps working as well. And so, yeah. Not the JIT, but you can compile to C and using native compilation, yeah. So you can do your main development on PC and then compile and publish on mobile, yeah. Other questions? Yeah.
Have you thought about compiling to WebAssembly?
To WebAssembly? Well, through HashLink, I think it's quite possible because it has small runtime. The problem with WebAssembly, we talk about it, is some people ask me about Haxe and WebAssembly, and that's no garbage collector in WebAssembly. So you need to have one for running X content anyway. So either you go through X to HTTP, then you compile to WebAssembly because it has a very good garbage collector and everything. Or you can, if you want maybe smaller runtime, HashLink is maybe smaller than HTTP, I guess, maybe about the same. And well, both should be feasible.
There's no official support yet, but it's theoretically possible.
No, it's not, I mean, yeah, it's a bit more than that because, yeah, the toolchain is already there. You have compilers to compile to output C++ or C from HashLink or XCPP, and then you have compilers to compile CPPs to WebAssembly. So the tools are there. Just, I mean, the workflow depends on what kind of application you want to build. So it's more about up to you. We don't enforce so much the workflow in Haxe compiler side. It's just.
Actually, not sure it's going to be any faster because the things you match the API already pretty well, right? It's designed around WebGL calls. You can't embed the WebGL calls.
Yeah, and WebGL calls in WebAssembly are not possible. I mean, maybe
it's possible, but
it's possible, but
it's going to be no more efficient than going.
Yeah. You don't win much doing that, I guess. Yeah. And I mean, when you make games, most of the time is spent on GPU, and compiling it to WebAssembly versus JavaScript or versus anything will not change much for this, because you have CPU, which is used by your game logic, and drawing is done on GPU anyway. So no matter what technology you use, in the end, it's more about optimizing your shaders maybe, or optimizing your game logic maybe a bit if you are CPU bound, but there is really less and less games being CPU bound. If you are looking for high quality games, you are not most likely GPU bound than CPU bound. Other questions? No? All right, thank you. And and you can find everything up. Okay, we don't have yet a website with something we are working on. You can check on Heaps.io, Heaps. This is the source code. And there is a bit of very slight bit of documentation, but we are working on improving it. And you can see all the source code is open source, so play with it and have fun. Thank you.